probability. And so today is going to talk about what is a set, and then we're going to do some Venn diagrams. And you probably have seen some Venn diagrams in different situations before. The one thing I like about this probability unit is you can kind of see how it's used in a lot of different scenarios. Okay, what are the chances of something happening? And you hear about people talking about probability all the time. And we're not necessarily going to do probability today, but all of these things are going to tie into getting into probability later on in this unit. Today we're just going to talk about like what things are in a set, and then we're going to talk about how many different items and things like that based on what we have. And so a set is essentially a collection of objects. And it could be a lot of different things. You could talk about students in a classroom. Okay, sometimes people talk about something if they are a big collector, maybe whatever it is that they collect, football cards or stamps or what coins or whatever it is, might be a collection of something, right? And so those are places where you might see a collection of something. If I talk about students in a classroom, then each individual student is what we call the element. So if I was to list everybody's name out that's in this class, that is the set, and then one person would be an element. And so everybody would be their own element. We typically use a capital letter to name a set. If a set has nothing in it, then we call it an empty set. And the way that we could identify that is sometimes we've seen the zero with a slash through it. We call that a null set or an empty set. Or we're going to see these bracket symbols today, and that puts everything in that set. And so if I put bracket symbols and there's nothing inside those brackets, then that means that set is empty. Okay, and we're not going to do every single example today. There's going to be a few things that we're going to skip just for the sake of saving a little bit of time today. The good thing, and some of you guys might like this as a change of pace, but not all of these are, when we think of it, it's like not doing math problems. Like trig was pretty heavy math problems, right? We had to set up equations, we had to use our calculator. Some of these aren't going to be necessarily always be math related, even though we're using them as a math term. So if I said, make a set of all the states that begin with the letter O. So what U.S. states do we know of that begin with the letter O? Oregon. What'd you say? Oklahoma, yeah. Ohio. Any others? I think that's it. I think there's 3 of them. Okay, another couple of terms, and it defines them over here. A finite set is something that stops. It doesn't go on forever, okay? So here, this is finite. There's only 3 things in the set. So finite means that it stops. I have a particular number of things that would be in that set. We've heard the word infinite before. Infinite means to go on forever. So if I have a set that goes on forever, okay, like for instance, counting numbers, right? Numbers can keep going on forever. That would be infinite because I can keep counting. I can always add more to it, right? And so numbers would be something that would go on forever. If we talk about the set of real numbers or the set of integers or things like that. Okay, prime numbers. Anybody know what a prime number is, first of all? Okay, only itself and 1 can go into it. Okay. What is the lowest prime number? A lot of people think it's 3. 1 is not really considered prime because 1's already itself, so we're talking about this number and 1. 7 is a prime number, but it's not the lowest one. 2. Yeah. 2 is the only even prime number. All even numbers, 2 goes into them, right? But 2 is the only even number that's also prime. So I could start listing out prime numbers. 2, 1 and 2 goes into it. 3, 1 and 3 goes into it. 4, nope, okay, because 2 goes into 4. 5 is prime. 6, no, because 2 and 3 go into 6. 7, 8 is not prime. 9 is not prime. 10 is not prime. 11, okay. At some point I got to stop, right? Because prime numbers go on forever. And so whenever we have a set like this that goes on forever, we put some dots at the end to show that it's going to continue. And then we put the brackets at the end. The brackets aren't anything special. I just kind of, some squigglies is really all I ever do. Just to show that it's in a set. And this one is infinite because this set goes on forever. I could continue to list out prime numbers forever, right? There is no stopping at this point when we do prime numbers. Okay, multiples of 4 would mean numbers like 4, 8, 12, 16, 20, and so on. Okay, 4 goes into them, essentially. Give me a number that is 4 and also odd. You guys can't come up with one? I wonder why. Because it's a empty set. Okay, then nothing exists, right? There are no numbers that are multiples of 4 and also odd. Okay, and those are the two ways. You don't have to do both, but you could do either one of those to show that there's nothing in that set. Okay, I'm not going to worry about universal set. We won't talk about that one. Okay, a compliment, it's not like a compliment saying, hey, you look nice today, right? That's a different type of compliment. That's spelled with an I instead. This is a different type of compliment. It's a set of all elements, and so the universal set is all elements, right? If you're not in that set, then that's the complement of that, okay? So, for instance, I could do all geometry students. That would be kind of like a universal set, right? All geometry students in Bueller High School, okay? But then, somebody that is in Mr. Frecking's or Mrs. Heron's, if I said the set of students in Mr. Ruta's class, they're still geometry students, right? But they're not in the other teacher's classes, okay? And so those would be people that are still in geometry but not in Mr. Ruta's class. The way that we would denote that is A, and there's just a little apostrophe here. A with an apostrophe, and the way that we read that is not A. Okay, so here's U. U is the set, the big set of numbers. 1, 4, 7, 10, 12, 15, 17, and 20. A is 4, 10, and 17. What numbers are not in A? So it would be all the numbers that are in this set that are not in A. So we're going to list out all the things that are not in set A. So we would start with 1. 4 is in A, so we don't list 4. 7 is not. 10 is. 12 is not. 15 is not. And 20. So those are the numbers that are in this set, but not in A. So we just read this as not A. And we use the symbol because it's a little bit easier to do that rather than writing not A every time. We just know what that means. Okay, intersection. If we have an intersection of something, when two streets meet, they intersect, right? That's why we've got to have a stoplight there, otherwise there'd be all kinds of crashes. And so here we're talking about two different sets that are intersecting one another. That means they have something in common. And so when we look at this, the symbol that we use for this is A intersection B. I kind of think of this as, it kind of looks like an N. It's not an N, but it kind of looks like an N. It's just, basically it's an upside down U, which we'll talk about here in just a second. But it kind of looks like an N, so I think about it as intersection. It's just the symbol that we use for intersection. So whenever we have that symbol, it says what numbers are in both A and B. So the key word here is and. We're looking for, and wording is everything throughout this chapter, okay? What numbers are in both A and B? So now we're going to list out the numbers that are in A and B. Well, we got 2 is in both. We got 10 in both. And then we got 17 in both. And that would be our set. Those are the numbers that are in both A and B. Okay, the other one that we're going to talk about is the word or. Instead of and, this one's an or. So we want A or B. The symbol we use here looks like a U, okay? Because it's a union, so U for union. But this symbol, just the way that we would read this is A or B. So whenever I see this symbol, it means or, okay? When I see the one that looks like an N, it means and. And there's a big difference between those two, okay? I always use the example, like if I go to a birthday party and they're serving cake and ice cream, right? Sometimes you might say, do you want cake and ice cream? That means I want both. I'm a cake and ice cream guy, right? I like them both. Sometimes people might choose and say, I'm not really an ice cream guy, so you could do one or the other. I just want cake or I just want ice cream. It's one or the other, okay? You're not going to get both. So do I get both or do I get to choose between the two? So or and, big difference between those two. So in this case, when we do an or, my set is typically going to be bigger. Okay, we're going to talk about more numbers here. So we're looking at numbers that are in one or the other. Okay, can they still be in both? Absolutely. That means they're still included. So I'm going to start with 2. Okay, and I'm going to list them out in order from smallest to largest. 2 is in both. I don't need to list it twice. I just need to include it. Right? So 2 is included. The next biggest one is 4. 4 is in B, it's not in A, but it's in one or the other, so we got to include it. And then we got 6. 10 is in both, but I don't need to list it twice. 12, 13, 15, 17, and 20. Okay, so it's a pretty long list. We're saying these are all the numbers that are in one or the other. So everything that's included in one of those two sets has to be included in my big set, my OR set. Okay, these are, and we're going to see some Venn diagrams today. These are the things that we're talking about when we see these Venn diagrams. Okay, the first one, we talked about a complement. Okay. Once again, if I think of like, let's say this box represents all geometry students at Bueller High School, then maybe the circle here are just the people that are in Mr. Ruda's class, right? So then people that would be in the box would be people that are in geometry but not Mr. Ruda's. So the people that are in the box are not in A, okay? And that's the way you're going to read it, okay? I just want to kind of use an example so you could kind of understand what's going on. Okay, an intersection. If I have A intersection B. If I use classes again, okay? if I said, what students are in geometry and band? So maybe circle A represents students that are in geometry. Maybe B represents students that are in band. And then there's going to be some overlap, right? There's going to be some students that are in both. So the overlap here would be how many people are doing both classes. There's also going to be some students outside of that that aren't in either one. Students that are in Algebra 2, that aren't in band. Okay, there's going to be students that don't fit in any of those categories. And so that's still the box. The box is outside of that. Okay, and then the union, and I'm going to color that in. Okay, same thing over here. Not A would be everything outside of A. Intersection of A and B would be where A and B overlap each other. The union of A and B, we use A union B, then that would be everything in those two circles. If it's an A or B or the combination of the two. Anything that's in anywhere in that circle. So we're going to do a couple of different things today with Venn diagrams. We're going to talk about how we can make a Venn diagram and place things where they belong. And then we're also going to answer questions about some Venn diagrams as well. Okay, so first of all, U is whole numbers that are at most 8. Where do whole numbers start at? I know it's been a long time since we've talked about types of numbers. If you remember back to whole numbers, where do whole numbers start at? Anybody remember? So natural numbers start at 1. Whole numbers start at 0. Okay? I kind of think of it, whole has an O in it, and so I kind of remember whole as an O or 0. Okay? So U would be all the numbers 1, 2, all the way up to 8. At most 8, which means we're including 8. So U would be all the numbers from, oops, I should have included 0. That's my fault. I just talked about it, but I didn't include it. U would be 0, 1, 2, all the way up to 8. Okay. A is 2, 4, 5, and 7. B is 1, 4, 7. And so what we're going to do here is we're basically going to start inside and work our way out. Okay? And so what do A and B have in common? 4 and 7. So those two numbers go in here. That's the intersection of A and B. Okay? Then the numbers that would go here are the numbers that are in A but not B. Well, we've already used 4 and 7, and then 2 and 5 are in A but not in B. So they're not in that overlapping area. For B, 1 is the only number that's in B but not in A. The numbers that go in the box outside of here are the numbers that are in this set but we haven't used already. So then we're going to look at numbers like 0, 3, 6, and 8. You can put those anywhere in that box because they're in that big set, but they're not in A and B. A, and where I put them really doesn't matter. Okay, so not A. Not A means it's in this set, but it's not in this circle, right? And so we're just looking at the circle here. So the numbers that we're going to use here are 0, 3, 6, 8, and 1. Typically, we will list them in order. Okay, this one here, we read it as not B. what numbers are not in B. So every number that's in this box that's not in this circle. So it would be those again. So I'll kind of skip over that one because we kind of already did not A. This one means and so the only two things that are in A and B are 4 and 7. Okay, and then finally A or B, and I'm going to write or underneath this, so remember what this means. Everything that's in either one of these circles. So we're looking at 1, 2, 4, 5, and 7. Okay, I always like to put them in order because I think it's easier to organize. Or at least for me, it's easier to grade probably. But as long as you include them in there, typically we would want to put them in order from smallest to largest. Okay, subset. This is another symbol that we're going to see. B is a subset of A. So it's a smaller set. Okay, natural numbers less than 10. So here it's asking me if one set is a subset of the other. So in this case, are the numbers 2, 5, and 9 a subset or a smaller set of the natural numbers less than 10? Well, we just said natural numbers start at 1 and go on forever, but all the numbers less than 10 would be 1 to 9. So are 2, 5, and 9 natural numbers that are less than 9 or less than 10? And they are. So here we would say yes. B is a subset of A. Okay, number 9 is kind of tricky. If I just said 4's in a deck, and on here I gave you all of the decks, all the cards in a deck, okay, then I could say that 4's are the subset of the entire deck. But here we're looking at all hearts. Okay, so are all the 4's in a deck subset of just the hearts? Well, no, right? We do have a 4 of hearts in a deck of cards. But what about the 4 of spades or the 4 of clubs? Those are not part of that same subset. Okay, so on this one, we would say no. Because all I got to provide here is like something that would be, in the past we've called it a counterexample, something that proves it false. So if I had a 4 of spades or a 4 of clubs, that would be something that's not in that smaller subset. So it's here's the set. What's something out of that set? That would be a subset. All right, on the next page, we're going to do a couple of these together. Okay, let's look at number 1. They already give us the Venn diagram, and we're going to use the Venn diagram to answer questions. Okay? And so use all the different scenarios and things that we've talked about. We talked about how we could make a Venn diagram, but here on this one, the Venn diagram is given to me, and we're just going to look at it and answer questions. I'm going to tell you right now, the thing that you got to pay attention to the most here is it an and? Is it an or? And or are two very small words, but they have big meanings. Okay, and so we got to read these problems carefully because that's probably the thing that throws people off the most here. That's why we're doing these things before we do the state assessment. So when you read these, you kind of understand what it's asking when it asks me some of these questions, because you're going to see some probability questions more than likely when you take it. So in this case, how many senior boys play football and wrestle? What do you think? 9. Okay. That would be the overlap, right? the whole box represents senior boys. Okay, who do one or the other, and some do both. How many senior boys play football but do not wrestle? 18. Okay, they're in the football circle, but we're not including the ones that wrestle as well. How many play football or wrestle?
39.
How much?
39.
39. Okay, how'd you get, Cora?
Add 18, 12, and 9.
Yep. Everything that's in either one of those circles. 18 plus 12 plus 9. Okay, and that gives us 39. How many senior boys wrestle? 21. Okay. We're just going to add everything that's in the wrestling circle. So 9 plus 12. Okay. I'm going to jump down to, this is the next page. Okay, this is number 6. And I want to do this one because this one has 3 events going on. Okay? And so I kind of like this one because I've actually been to this amusement park, Cedar Point. Cedar Point is an amusement park up in Ohio. And my sister actually worked there one summer. She did like an internship. And so I rode up with her and I helped her get settled and stuff at the beginning of the summer. But we went up right when school was out. And Ohio at the time was still in school. So because I was there and because she worked there, she got me into the park for free. And Cedar Point is like the roller coaster capital of America. It had 20-some roller coasters. So if you're a roller coaster enthusiast, then this is the place for you. And what was cool about it was we were able to, my wife and I went, and we were able to, because they were still in school, nobody was there. All the kids were still they hadn't gotten out of school yet for the summer. And so once we got off one ride, we were able to just go jump right on the next ride. There was no waiting in lines or anything. And so it was a great time to go there, and it was a lot of fun. Pretty cool place. And it sits right on one of the Great Lakes. Sits on, I think it's Lake Erie. It sits right on the lake, and so the Great Lake is sitting right out there. It's a pretty cool place. All right, so these are 3 of the roller coasters that are at Cedar Point. The Venn diagram below represents the results of the survey. Okay, how many students just went on the Maverick? Only the Maverick. 27. I can't include these numbers here. These people right here rode the Maverick, but they also rode another roller coaster, right? These 27 here only rode the Maverick. They're in the Maverick circle, but not any other circle, okay? How many students went on the Blue Streak or the Millennium Force? Okay? How'd you get it? Yep. Okay, yeah. Because of the word or here, okay? We're not saying and, okay? One or the other. So anything that's in the Blue Streak or the Millennium Force. So it would be all of these plus these 2. Anything that falls in either one of those 2 circles. We add them all up. Okay? So you got to read these carefully. This one used the word or. Part C uses the word and. How many students went on the Millennium Force and the Maverick? Okay, 33. We're going to add 19 and 14 together. Okay, and you might say, well, they also did the Blue Streak, and that's okay. It doesn't say anything about the Blue Streak, but we know these 14 people did both, and so did these 19 people. Okay? We can't include any others because the rest of them only did one or the other, not necessarily both. Okay, how many people went on the blue streak? So all I got to do here is look at the circle that represents blue streak, 24, 21, 14, and 10. Anything that's in that circle would be included. I think that one's 69. Okay. And then the last one, this one's kind of a tricky one, I think. How many students went on the blue streak and Maverick, but not on the Millennium Force? How much?
10,
Okay, how come 10, you know?
because there's 10 that are both on Blue Streak and Maverick, but not in the middle.
Yep. Okay, so these 10 people here rode Blue Streak and Maverick, but we can't include these because they can't go on the Millennium Force. So it would only be those 10 people right there. Okay, and there's tons of questions that could be asked about this, right? So a lot of the questions about problems like that, you're going to answer individual or specific parts, but you just got to read it carefully. Okay, I can't stress that enough. You're going to hear me say that a lot throughout this chapter. Probability stuff isn't too bad, but when you get to like the test and quiz in this chapter, then you got to make sure you take your time to read through it. The math isn't necessarily hard. It's just make sure you interpret the question correctly to what it's trying to ask us. Okay, and that's a great rule of thumb when you take any standardized test. That's coming up. State assessment, ACT down the road. This is what you guys are going to be taking. They give you problems that are there to try to throw you off, right? And that's what some of these are going to be. They're going to try to throw you off by giving you different scenarios. All right. Assignment for today. I'm going to pass out the homework page to you here. So there's two separate packets. There's the homework packet, which we're going to do, or there's the note packet, which you've got right now. That's where we're going to do our notes of the next couple of weeks. Even when we get back from spring break, we'll continue working with probability stuff. We have a quiz next week, and then we'll have a test. I think as of right now, the test, we're planning on the test like right before we take the state assessment. And the state assessment, I think, is planned for March 31st and April 1st. It takes 2 days to take the state assessment, so all sophomores will be doing that.
Are the problems in the notes packet graded?
They will be, yes.
Okay, so
Yeah.
we should do them?
Oh, like the ones that we didn't do?
Yeah.
No. You don't have to finish out. Because there's so many examples in there, we're not going to do all of them. All right, so I'm going to pass out the homework page to you here in just a second. When you get it, at the top of it, it's going to say homework 1. And here's the numbers that we're going to do from homework 1. Okay, so you don't have that yet, but I'll give it to you here in just a second. And that's what we're going to use. Okay, the one page on Venn diagrams where it says reading Venn diagrams, I want you to do number 2 on the page that says reading Venn diagrams. So you can start on that one right now, the one with yoga and aerobics. And as I'm passing the